Welcome to Networks Professionals.
So let's get right into it. We're always hearing about AI getting these amazing, perfect scores. But what if I told you that a 100% score could actually be the sign of a really, really dumb AI? In this explainer, we're going to pull back the curtain on AI performance and see why the real test is all about the questions an AI has never, ever seen before. Okay, so picture this. You're an AI developer. You've just spent weeks training your new model. You've run a quick check on the data you used to teach it, and what do you see? Boom, 100% accuracy. You've done it. You've created a genius. Time to pop the champagne, right? Well, hold on a second. Not so fast. See, a perfect score on the practice test is one thing, but it doesn't answer the one question that truly matters. Is this AI actually smart, or has it just gotten incredibly good at, well, cheating? And that question, it's right at the heart of building AI that we can actually trust. To really get what's going on here, let's use an analogy that I think we can all connect with. Let's call it the A+ student problem. We've all known a student like this, and it turns out AI can fall into the exact same trap. Think about a student who's studying for a huge final exam, but instead of learning the material, they just get their hands on last year's test and memorize the answer key, A, B, C, A, D. They can spit those answers back flawlessly. They'll ace every single practice quiz you give them. But did they actually learn anything? Of course not. This right here, this is the exact trap we have to avoid with AI. And in the world of machine learning, this very specific problem has a name. It's called the overfitting trap. And honestly, it's one of the biggest headaches that developers have to deal with. So here's the deal. Overfitting is what happens when a model doesn't learn the actual patterns and rules. Instead, it just memorizes its study guide right down to every little detail, even the weird stuff like typos or random noise in the data. It becomes a perfect copycat of its training material, but it's completely lost the second you show it a new problem from the real world. And this chart just makes it crystal clear, right? On the left, you've got memorization or overfitting. Yeah, you get that high accuracy on training data, but it's brittle, it's unreliable, it fails when it matters. But on the right, that's the goal. That's generalization, true learning. That's when you get strong performance on new data, because the model is robust, it's reliable, it actually gets it. So how do we make sure our AI student is truly learning and not just cramming and forgetting? Simple. We give it a final exam with brand new questions. In the AI world, we call this the train-test split. You know, it's a really elegant idea. We take all the data we have and we slice it into two piles. The big pile, usually about 80%, that's our training set. This is the homework, the textbooks, the lectures, all the study material. But that other 20%, we lock it away. That's the test set. It stays completely hidden until the final exam. And the whole process is a really simple two-step. First, we teach the model. We just let it loose on that big 80% training set to find all the patterns it can. Then, and this is the important part, only after its school days are over do we evaluate it. We pull out that secret 20% test set, the stuff it's never seen, and we see how it really does. Now, this second step isn't just about giving it a grade. It is so much more important than that. You can think of it as the AI's final absolute reality check before we let it anywhere near the real world. And this quote just nails it. It's a reality check to ensure the AI behaves as expected before it is used by end users. This step is what makes the difference between a cool science fair project and a reliable tool you can actually trust in a hospital, a bank, or even in your car. So how do we grade this thing? Well, it's not just a simple A through F. It's more like a detailed report card. Sure, there's accuracy. That's the easy one. How many questions did it get right? But that's not the whole story. We also look at precision. That asks, when the AI says something is true, how often is it actually right? Super important for avoiding false alarms. And then there's recall, which is kind of the opposite. It asks, of all the things you should have spotted, how many did you actually catch? Looking at all these together gives us a way richer picture of how the AI will actually perform. So why all this fuss? Why is this whole process of splitting data and giving a final exam so important? Well, because at the end of the day, this is what makes AI trustworthy. It's everything. Because a proper final exam does a few absolutely critical things for us. First, it stops that memorization problem, what we call overfitting. It lets us measure if the AI can actually generalize what it learned, And crucially, it helps us find hidden errors or biases before they cause any real-world damage. You put all that together, and it's how we start to build AI that we can actually count on. So the real takeaway here is this. The train-test split isn't just a technical step. It's the core process that takes an AI from something that looks smart on paper to a tool that's actually reliable enough to use in our lives. It's really the difference between a clever parlor trick and real intelligence.
And that leaves us with one last really important question to chew on. As AI gets woven deeper and deeper into our world, making decisions in medicine, in our legal system, everywhere, it's not enough to just ask if it got a perfect score. The real question we need to be asking is, how can we be sure it passed the right test? Thanks for watching.